This lab is called Don't Nickel and Dime Me. In this lab, we're looking at Newton's laws, more specifically, Newton's third law of motion. For this lab, you will need a nickel and a dime. Hence the title of this lab, Don't Nickel and Dime Me. Doesn't have to be a nickel and a dime, you just need one larger coin, one smaller coin. So what you're going to do for this lab, you're going to take the nickel and the dime, you're going to put them on the table, and you are going to put them under your finger and slide them together. So as you can see, during the collision, that dime goes flying in one direction, the nickel kind of comes to rest. Now, when we're looking at Newton's third law, right, for every action, there's an equal and opposite reaction. So when they collide, right, I know that the nickel is applying a force on the dime and the dime is applying a force on the nickel. So some questions I can ask myself is, well, which coin is applying a larger force in magnitude to the other coin? I can also ask myself, well, which coin applied that force first? I can also ask which coin applied that force for a longer period of time. Now the key to this one and looking at Newton's third law is, what was the effect of those forces on the coins? Were those effects the same or were they different? Now to answer this question, we need to look at Newton's other two laws. Newton's first law of motion is known as the law of inertia, in which it explains inertia, where objects have the tendency to continue doing what they're doing unless unbalanced force acts upon them. So inertia is resistance to change in motion. So I gotta ask myself, well, which one of these coins has more inertia? Now Newton's second law of motion is just written as this equation. Now in Newton's second law of motion, he quantifies how much acceleration is produced by a given net force. And the acceleration equals the ratio of net force to mass. So when these coins collide, I gotta look at the forces being applied. I know that those forces are equal and opposite because of Newton's third law of motion. For every action, there's an equal and opposite reaction. But I have to ask myself, was the effect the same and why? And to do this, I have to look at the inertia of each coin, the resistance to change in motion, and I have to look at Newton's second law of motion, which is written as the equation, acceleration equals the ratio of net force to mass. So once again, this is Don't Nickel and Dime Me.